Online student guys, go to your drive, go to PCA folder and the code. Guys, run this code. PCA1. Guys, run the code. Done. Ragini. Anisha?
Answer.
Yes, sir.
Yes, sir.
आप लोग का वॉल्यूम क्यों बंद हो जाता है? Guys, where is Shantanu? It's coming. Priyanka. Guys, when to use PCA? Anyone? We'll do our revisions once. No. What is the use of PCA? Is used for grouping. Point number 1. Okay. How we do grouping? Column wise. ये clear हो गया? So we are grouping column wise. The way we group, okay, on what basis we group, guys? On the basis of how they are related. So we call as how they are correlated. So which variable is highly related, that variable we club. To compute correlation, what type of data we required? Numbers. Clear? In PCA, we study some parameter, guys. Eigenvalues. What is the use of eigenvalues? To find how many grouping parameters, how many groups is possible. Condition is more than one group. Less than one, do not group. Clear? Also, using eigenvalues, we can find how much percent data explained. What is the threshold? More than or equal to 50%, then we can say a grouping is correct. Clear? Anything else we learn, guys? Shall I move forward? Everybody on screen. Okay. Now, guys, I have taken a data set where we have clean data. I've given you data set in the code also. Here we have a taxi, we have a distance, we have market, we have carpet, builder, what type of parking we have, city category where I have my own flat, in which city I have. Then we have a rainfall, how much rainfall we have, and then we have your house price. Can I say price of the house depends on this parameter, guys? Example, let's say there is one person who lives over here. Okay, guys, my drawing is not too good. You need to bear it. This is the house of Rahul. Rahul stays over here. Rahul house from here till market. Okay. Can you call distance? How much distance you travel, guys, to market? 5250 means this is in meter. House from to taxi. Distance to, or we can say this is hospital. What is the data, guys, for the first row? 9796 10703. Second, how much area the Rahul houses. That's difference between build-up and carpet. Carpet which we leave, which we use. Build-up include construction plus your carpet. How much is the entire house carpet? 1659 and build-up area. Every time the carpet area will be less than build-up area. Vice versa is not possible. If it is possible, it is the without building flat. It's just a ground. Okay. Second, we have parking. So when you have a flat, guys, whether you have a parking or not. First question. Second, if you have a parking, it's open parking or with or let's say covered parking we have. Cover means inside the building. In which city your flat is? City A is Mumbai. City B is counted as Pune. Okay. Same way, then we have in which city we have high rainfall and what is the rainfall unit? Can I say based on that the price of the flat get changed, guys? The 1 BHK price in Bombay is 1 crore 30 or 1 crore 10 minimum. Okay. In Pune, in 1 crore we get 2 or 3 BHK. Okay. So this difference occur in terms of city-wise also. Now my question for you, if I want to do a PCA, what type of data can I take? Numeric. Okay. So guys, I have taken all the numerical data. Can you see over here? I have taken distance to taxi, market, hospital, carpet, build-up and rainfall. So I'm just removing this two. And price of the house is your Y variable. So we cannot take Y. We have to take all. Clear? So from data PCA, take all numerical variable, assign in X3. Clear, guys? So can I say this all are my X variable? Anyone have any question, Vallabh? Okay. Now between this X, first we need to confirm whether they have interrelation or not. They have multi or not. They have multi-collinearity or not. I just compute correlation just for our safety. Okay. Guys, anywhere we have collinearity. So you said taxi, distance and hospital, they have high interrelation. Build-up and carpet and rainfall is separate. So can I say all the distance variable club will become one group? Carpet and build-up should become and club and become one group because grouping done on correlation. Wherever they have highly correlated, they should make one group. Clear, logical, guys. This is logical we are discussing. Let's decide how system do. PCA is affected by scale. Now, guys, distance value is coming in meter. Parameter value, which is the carpet and build-up, coming in square feet. Can I say scales are different? Can we come to same scale? I teach you something known as min max, normalization. Remember KNN? So I just convert using your standard scalar. Okay. From a scalar, I want to do pre-processing, importing which function? Standard scalar. Okay. Assigning in SC. Then SC dot fit transform. Fit means supply, transform means convert your data. Which data I'm converting, guys? X3. So if you want, I will write for you. We have taken extreme data. We applied some transformation and we have makes extreme 1. This is your original data. Vallabh, give your mobile phone, please. दे दो। फोन 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 राहुल राहुल आपको भी देना है फोन? वहीं रखो। Just 20 minutes. Okay? Then you will get time for your discussion. Don't worry. Okay. I just convert data by using a standard scalar. Okay. Once you convert data into standard scalar, guys, the rule of standard scalar say the mean of every variable will become 0 and standard deviation will become 1. This rule hai after conversion. This I'm doing just for verification. If you do not do it, also okay. Okay. How many x we have? 6. Can I say we have 6 1? This is the original data, guys. This data come after conversion. Easy to read. Anyone have any question? Can ask, please. Can I say this come in data frame? Original one. This come in array. Now, guys, I want to do a grouping. So, according to you, logically, how many groups can we make? Here we have 6x. Can I make 6 group? Output is useful. So, जो data है वही same groups बना रहे हैं तो what is the need? If you have 60x and you make 60 group, make any sense? So our group always has to be less than the number of x. Clear, guys? Now question comes, how many groups need to be made? Okay. Let's say I decided I want to make how many groups? 4. How I decided this? I'll write over here as 4, guys. Clear? From scalar, I want to decompose. Decompose means break. Import function, PCA. In PCA, I want to make how many component groups? 4 groups. Signing in PCA. PCA dot fit means apply the model on. Can I say we are building model on this? And model name is now principal component. Clear, guys? Now we redefine some eigenvalues because eigenvalues give a justification how many groups has to be made and how many I have done. I have done 4 groups. Let me run this. First group, what is eigenvalues? 2.2. Second group, 2. Third group, if I round off 2, if I round this, I just round off the number. What is the condition for eigenvalues, guys? How much? Greater than or equal to 1. How many are more than 1 or equal to 1? First group, second group, third group. Can we make 4 group, guys? No. Can I say my selection of random is wrong? Got the point? Easy. So eigenvalues defined to make how many number of groups? 3. So is this concept clear? How we get this 3 number? Clear for you, Vallabh? Okay. Now question comes, I'll make 3 groups. I'll go up and change to 3. I'll run this again. And again I'll run this one. Clear. In first group, what is the eigenvalues? 2.6. Okay. How many variables we have? 6 variable. Anyone can do 2.6 divided by 6 is how much percent? So from principal component, which is the model, give me explained variance ratio. Ratio will give you percentage. How much I have, guys? 37. Exactly match close to. So first group explain how much percent data? 37. Second group explain how much percent data? Third group, sum of all. So can I say 87%, or we can say round off to, let's say 88% data we explain properly, guys. Clear concept, clear. So out of 4, we decide to make 3. Within using 3, we are able to explain how much percent data, guys. So 3 groups explained 88% data. How much percent data loss, guys? 12%. Clear. Any question? Let's skip this part to avoid confusion. Okay. This is your train data, original database. Your transform data, remember, extrain 1. Now, guys, I just have to have equations. We'll come to equation later also, guys. 3 point I'm skipping, I'll come again. One is your mean, covariance, and equation. Now, this is your original data. What I do, I just make a data frame. So using principal component, my model, okay? This model, I say apply on extend 1. Apply also and convert also. So I'm converting my data and making a column called as transform data. Extend 1 have how many columns, guys? After applying model, I'm converting to how many groups? This file name, what we have kept as? इसका नाम है transform data. Clear, guys? Any question? Please ask. Structure clear. Original to standard scalar. We have make the model by using 3 groups, and that model using to convert data. Can I say my data get reduced, guys? First, in original, how many data we have? 6. Number of rows remains same after conversion. Anything happens in column? So how many we have now? 3. So from 6 to 3, can I say we have done data reduction? Can I say, guys, I have made 3 groups? Clear, easy or difficult? Now, guys, I just convert this transform data, okay, into a data frame called as principal DF. Transform data come into data frame with 3 column names. Clear, guys? ये data है. This is your data. Z1, Z2, Z3 I'll teach you. तो 3 groups तो थे, 6x थे, उससे कितने groups बन गए? 3 groups. This is your data, guys, not Z1, Z2. Clear. So now, if you remember this 6x, they have multicollinearity. After applying PCA, 3x has to be, how we check, guys, they are independent or not independent? Correlation. For DF, principal DF, I want to compute correlation. Round up number by 3 digit. Wherever we have values more than 0.5, give me color as PC1 with PC2. How much relation we have with PC3? Can I say all the principal component data is independent? Yes. ये clear हो गया? Any question anyone have? So can I say all my PC's data are independent? Now question comes, guys. The data which I have is 1.46, 1.00. This number, how we get this? How we get this number? Remember teaching something known as Z? Yes. How many groups we have made, guys? 3. So how many equation I will have? 3. Z1, Z2, Z3. ये clear हो गया? Z1. This equation is my Z1. This equation is my Z2. This equation is my Z3. So these are nothing but coefficient for every X. Clear for everyone? Or do you want me to repeat? I'll repeat for you guys. Scalar means नहीं, ये डायरेक्टली इक्वेशन, ये टोटल सम में स्क्वायर करने के बाद ये नंबर्स आते हैं. स्टैंडर्ड स्केलर है वो वाला फॉर्मूला इससे ऑटोमेटिक कैलकुलेट करता है. एक का सम डिवाइडेड बाय टोटल कॉलम का सम डिवाइडेड बाय टोटल सम. स्टैंडर्ड स्केलर डिफरेंट है. ये हमने कैलकुलेशन किया उससे ये फॉर्मूला है. यहां तक हम सिर्फ डेटा बना रहे हैं. ओके, यहां तक हमने सिर्फ डेटा बनाया और हमने कुछ नहीं किया. Still here clear? If you want, I'll repeat again. Till here we have make data. Here on this data we have applied model. Model is PCA. ओरिजिनल डेटा ऑलरेडी है ना रखा हुआ यहाँ पे. एक है लाउड बोलोगे प्लीज. ओरिजिनल डेटा के हाँ क्या गया हमने स्केलर डेटा पर किया. हाँ, ओरिजिनल भी बना सकते हो. स्टैंडर्ड स्केलर पे क्यों किया हमने? टू हैव एवरी डेटा ऑन सेम स्केल. अगर आपको नहीं ट्रांसफॉर्म करना है तो आप किससे बनाओगे डायरेक्टली? इट इज योर ओपिनियन. आएंगे ना, क्यों नहीं आएंगे? क्रॉस चेक करना होगा सेम है कि नहीं. स्टैंडर्ड स्केलर से क्या होता है, कैलकुलेशन फास्ट हो जाता है एंड आउटलायर इज कंट्रोल. दैट्स द रीजन वी यूज सेम स्केल. डू यू वांट मी टू राइट अगेन? चलो एक स्ट्रक्चर लिख लेते हैं. Guys, on screen we have X-ray. This is your original data. Every variable on different scale. So what we need to make the variable come on same scale? We apply standard scalar. इसका job क्या है? What is the job of standard scalar? To bring data on same scale. Till here what we are doing? We are making data. Step number 1 clear. Our data part is done. ये हो गया. Second, we have to build the model. Which model we are working on? PCA. First, we decide how many groups. We use concept, random, and we have make 4 groups. ये clear हो गया. Then this 4 groups we check their eigenvalues. We are getting eigenvalues, condition has to be more than 1. So this eigenvalue suggested to make how many groups? 3. So you should make. Ye clear ho gaya? Then again I'm writing step number 2. Again we repeated step number 2 with how many groups? Ye clear ho gaya? Any question? These 3 groups will have how many equation? Z1, Z2 and Z3. Till now clear, or should I repeat? This is your Z1 guys, Z2 guys and Z3. Ye clear ho gaya? Do you want me to solve and show you how it works? I'll copy this. Okay. Now what is the value for x train? This value? I'll multiply my x. Ye clear ho gaya? This is called as Z. हम स्केल डेटा पे मॉडल बना रहे ना. What is the value of x? ये clear हो गया. x1 beta 1 into x1 beta 2 into x2 beta 3 into x3. ये क्लियर हो गया. Next, what is beta 4 into x4 next what we have beta 5 into हमें ऐसे कुछ पढ़ा है ना. Into ये क्लियर हो गया. So what we have in Z1 guys now, कहीं पे मिस्टेक किया है मैंने. Where? What is the number I have guys? ये क्लियर हो गया. Let me open Excel file. I have done in Excel directly. ये बहुत टाइम लेता है ना. On screen guys, see this number. I'll zoom for you. Number clear? This number I written and pasted over here. चलेगा ऐसा? Instead of horizontal, I written vertical. Z2 clear? Z3 clear guys? Now what is the first data we have? This one. I pasted over here. Clear, clear. Anyone have any question till now? What is the equation wise? That one is beta into x. Correct? What is the number I am getting? Beta 2 into x2, beta 3 into x3, beta 4 into x4, beta 5 into x5, beta 6 into x6. After multiplying, I do a sum. What is the number I am getting? Same number, guys, you can cross check. So this is multiplying x with my beta will give me the transform data. Same way, I'll multiply my x with z2. What is the number I have with z2, guys? 1.004. I multiply x with my z3. What is the number? 1.0057. Same number. Exact match, guys. The way I do for one row, can I do for remaining row? Rahul, what up? Yes or no? The way we done for one row, can we do for remaining rows? So this is your transform PCA data. So from 6x, we make how many x? अब समझे numbers कहाँ से आए? Kiran, Anisha, Ragini, clear for you?
Yes, sir.
Yes, sir.
Okay, our question is, we have 6x and they have multi-collinearity. We reduce to 3x. Now let's confirm whether we have collinearity or not. We compute correlation and we found that every PCA data is independent. Clear, guys? So we make 3x. So we have Z1, Z2, Z3. This is called as model. Clear? Using this model, we make PCA data. How many data will make, guys? Can you remember PCA data 1, data PCA 1, data PCA 2, data PCA 3? So can I say I reduce from 6x applying PCA, I reduce to data which are PCA 1 to PCA 3s. Can I say that? 3 PCs. Can I say every PC is independent? So data reduction also happens and every data become independent also. Guys, what is the notation for independent? Clear, guys? Any question in the structure? Please ask. Easy. Next, moving forward, guys. Now what I do, I take my original data, the transform data. Okay, I take a number predict. I just combine and make data frame, my transform data, extend one, and my give the column name. I just convert this array into data frame. Clear? Next, I combine my scale data. So what I have done, okay, this data I convert into data frame and I've kept the name as scale frame. इसको हमने क्या कन्वर्ट किया है डेटा फ्रेम में. ये क्लियर हो गया. Now this scale data and this PCA data, what I will do, I will combine by using pd.concat and make the file call as final data. Clear? ये भी एक array में था, हमने इसको नाम क्या रखा है? This was an array and we convert to. So can I say now both are data frame, guys? Okay, we combine and make something known as logic clear. Why we are combining this? What is the need? I need to understand which variable is combining and becoming which group. Okay. So what I do, this is my data till here clear is my transform data till here and my PCA data till here. Logic clear, easy. I just make a function wherever we have more than 70, give me blue, less than 70, give me red, or otherwise give me black. Don't go by the function, just be on screen with me. Okay. I'll compute one by one. I run multiple times just to show you guys. I just make a matrix. If we have 3x, what should be the matrix size? Correlation matrix size. 3 cross 3, 4x, 4 cross 4. 9x. Clear. Why are we getting 9 cross 9? Okay. Now, guys, I say use ILSC. What is the meaning of ILSC? Subset. Take data from 0 to 6 before column, row wise. 0 to 6. Okay. Start column from 6 to 9. Convert to absolute and make a matrix. Clear. Now I just say wherever there is a correlation more than 70, give me color as blue. Now you tell me distance with taxi, where we have high correlation. In which PC? Distance with market. Distance with hospital. Can I say PC1 is made by the combination of these 3 parameters, guys? All distance data have combined and become in PC1. हाँ, उससे भी आप कर सकते हो, लेकिन it's better to make this type of matrix. Second, in PC2, where we have in second carpet, where we have high correlation. Carpet have high correlation with PC2. Build up. Can I say carpet and build up has combined and become PC2? And rainfall is separate coming in PC3. Clear, guys. So from our side, our analysis is done. Now question, what we submit to business. Okay, here we can say these are my coefficient Z1, Z2, Z3. This is my converted data. This data are nothing but my X data, X1, X2, X3. Can I take my Y over here? Can I say this become the task of linear regression without the loss of information? Remember, when we have multi-core linearity, we remove the X. Here we need to remove because every X is, every PC is independent. Logic clear, guys? Study done. Easy hai. So can I say PCA output we have used as input for supervised learning? Any question, please ask. स्केल मतलब डेटा है, स्केल मत सोचो तो डेटा है, यूनिट नहीं है, बिकॉज आप स्केल करते हो तो यूनिटलेस हो जाता है वो। हाँ, किया उसने वही, लेकिन वो यूनिटलेस नहीं कर रहा, तो बायसलेस नहीं रहा। हर बार ऐसे नहीं होगा ना, ये डेटा में हो गया। Can I say logical also? The programming, the PC programming has a brain to club which variable will go in which group. Guys, any question? So these are the things which you submit. Your coefficient in your data. This is the output of business, okay, which you need to submit. If business say, let's say you convert 6x to 3x in 3PC. Now can you run linear regression? So we can take this as x1, x2, x3. And we take our y as cost price. So what we have done, we converted unsupervised algorithm PCA output as in supervised, we take is as input. And next we will apply the algorithm called regression. This way, guys, a data scientist work. Output of one algorithm will become input for second algorithms. Nothing like this way. When we are doing linear regression, we have 60 for 10, 20 variable. We have removed manually. So removing is loss of information. Can we apply PCA? If you think like linear regression or gradient boosting, where we have multiple X, can we club and make a small group? Can we reduce the complexity of calculation? Got the importance of PCA, guys? Please ask. अभी हमारा कितना % एक्सपेंड किया था हमने? ठीक है. So 88% data expend. How much % loss? 12%. It's okay. क्या मतलब? तो उसका प्रेडिक्शन जब करना है तो इनपुट्स हमें पीसी वाले देते हैं वो फॉर्मेट में किस फॉर्मेट में बना रहे हो? पीसी. अभी वो स्केल डेटा छोड़ दो, वो पीसी तक था. जो स्केल डेटा जो था हमारा वो सिर्फ यही के लिए था. स्केलिंग एवरीथिंग इज डन फॉर पीसीए. हमें क्या मिल गया अभी? आउटपुट. ये आउटपुट हमारे लिए इनपुट है. फॉर मी दिस इज द डेटा. फॉर रिग्रेशन दिस इज माय So now what is your question? Prediction करना है तो y के टाइम पे कैसे cost price predict करना है. तो यहाँ पे एक y ले लो, ये इनपुट हो गया और एक y ले लिया आपने. लाइव डेटा पे करना होगा. लाइव डेटा पे करना डेटा मुझे नहीं है कि मेरा हाउस टू डिस्टेंस में आएगा वो मिलीमीटर में. डेटा कैसे मिला था आपको पहले? अनस्केल्ड. अगर लाइव डेटा पे करना है तो पहले क्या करना होगा आपको? सारे स्टेप्स करने होंगे पीसीए के. उसका आउटपुट क्या बनेगा हमारे लिए? इनपुट. फिर वो इनपुट यूज करना है रिग्रेशन पे, जैसा अभी किया है. सेम वे any data come in future, today, after 1 year, after 10 years, after same way, you have to follow the same steps. The way you repeat for train, same way you have to repeat for test, same way you have to repeat for live data. Our objective is to understand PCA till here. This is extra part which I have teach you. Okay, this is an extra part. Any question can ask, please. बोलो. नहीं वो स्क्रीन पे ही दिख रहा है कुछ और उसमें भी आपको. नहीं वो थोड़ा सा ना ब्लर हो रहा है ऐसा. रोटेट हो रहा है स्क्रीन. Guys, from my side the concept is done. Any question you have can ask. Can I say the way we have learned same way we have done? अभी आप फोन ले लो, सब दिखेगा। Online students, any question? Anisha, Ragini, Kiran?
No, sir. No, sir.
Easy to understand or very difficult?
It's a little bit difficult
Yeah,
than
but it's
other algorithm.
hard.
Okay. Anyone else found very difficult? Guys, if you do not want to transform now, you can also apply on train. Train पे directly आपका PC run करो. You will get Z1, Z2, Z3 and make data PC. Okay. ऐसे भी कर सकते हो. मैंने सिर्फ एक पॉइंट ऐड किया और कुछ नहीं किया. बस मैंने इसको यहाँ से ज्वाइन कर दिया और यहाँ से रिमूव कर दिया बस. How many steps? Step 1, step 2, step 3, step 4. Within step 4, we're done with your model. Okay, guys. Go through this point, guys. Okay. Shall I move to the next one? If you remember, guys, we have to do a discussion today on the distinguish between when to use which algorithm. Okay. Kiran and Ragini. Okay, let's start with the first basic one, linear regression. Let's start with linear. We'll start with logistic. And then what we have done? Okay, so tree factor is different. When do you use linear regression, guys? Y is numbers. An X variable. When do you use logistic? Correct. Y variable. ये कंडीशन परमानेंट है. X can be numbers भी possible हैं और Y तो कैटेगरी कंपलसरी है. X can be all category also. Y has to be category and X can be numbers or category. Clear? So if you're converting, then you're using it's okay, but most of the time do not prefer to use. My suggestion. Because how was 0 you can do, but my suggestion don't do. Because we have better algorithm than linear regression also. Like go for decision tree regression. Over there, we do not have to convert. Okay. Second, guys, anything else? What is the equation? Equation. Here we have how to check the model performance. Here what we use? Confusion matrix. Clear. Here we used to find relationship between X and Y. Here we find log relationship. Till here, when to use which one? Anisha, Kiran, Ragini, till here clear?
Yes, sir.
You have studied prior.
Yes, sir.
You have to explain is used to check the model performance. In terms of any change in X, how much change in Y? The formulas we explain that. Nobody will ask you to write the formulas, guys. It will be difficult. They will tell you when to use and what is the threshold. Why we use R square? Point number one, we used to check the model performance, how to read R square. Second, can you give me more elaboration on R square? Then you have to explain if accuracy is coming to as 0.8. So we say that 80% of the data we are able to predict accurately. So any change in X, okay, we can able to predict how much percent accurate? 80% accurate. Clear? Any question can ask, please. Easy hai. Can I see this way you have written the points, steps for linear, steps for logistic? हाँ, अब या तो confusion matrix के अंदर ही होगा ना वो. Here we have sensitivity also, specificity also. You can go for F1 square also. इतना complex नहीं है. A description, if you want, I can give it. थोड़ा सा over हो जाए, F1 square is a different topic. Any question on this? Anyone have? Shantanu clear? Kiran, Anisha, Ragini clear for you?
Yes, sir.
Yes, sir.
Well, confusion matrix. Now we done decision tree. We have done random forest also. We have done boosting also. Let's talk about simple one. I'm talking about oral boosting, but first I'll take gradient one. To make a decision tree, what we require, guys? Root node. So here we have three terminologies. Basic one, root node. Same terminologies guys we have. To make a tree, which splitter we use? Same we have used over here. Okay. If you're talking about, let's say in decision tree, in child nodes, what we use? Mode when we have classification task. What is the meaning of classification task, guys? Speak out. Y is your category. If I take average, what is Y? Numbers. So we call this as regression task. Same rule applicable over here also, guys. How many tree we make in decision tree, guys? How many tree we make on random forest? Okay. Here also we make multi trees, correct? ये clear हो गया? ऐसा कुछ नहीं है. Point number 5. Till here clear, guys? Now here we make multiple trees. Okay, वो clear हो गया. Can I say in random forest we make multiple subset? On each subset we make tree. Can I say here we make multiple trees? If I say, okay, every tree is independent. Guys, first tree depends, second tree depends on first tree? No. But when I say gradient boosting, can I say they are dependent trees? Second, guys, in decision tree, he improve himself. Improving? No. Random forest? No. Yes. Got the difference, guys? ये अपने आप को improve करते जाता है ना हर एक पैरामीटर्स पे, हर एक ट्री पे, by changing learning rate. It's keep on improvisation. As the tree increases, error decrease. लेकिन random forest में ऐसा नहीं होता है. So here it is. हाँ, we make error on tree. So guys, here we make point number 1. We make tree on data. We make tree on data. We make tree on error. Now, what is your question? Why you are not able to understand when to use which one? ये technical clearance है. Okay. What type of data we require to use decision tree, guys? अगर आपका Y कैटेगरी है और X चाहे कैटेगरी हो चाहे नंबर्स हो, which task is this one? Classification. Same rule we have over here, na guys. If your Y is number, which task? Regression. Okay. Now, guys, you speak. What is your doubt? Boosting में ये कैसे बोल रहे? Boosting I teach you for both the scenarios. I teach you for regression also. I teach you for classification also. Yes. हाँ, देखो, एक डेटा सेट पे you can apply multiple models. Select the model which has the highest accuracy. So that model is best for your data. Are you getting the point? Every model have different functionality, different. Decision tree, one tree. Random forest, multiple independent. Gradient boosting, multiple trees with dependent and sequential. अब ये तीनों में से कौन सा बेटर है in terms of technical point of view, guys? But random forest improve himself. Multiple trees we have, but tree also keep on improving. So can I say gradient boosting is the better one? And these are the scenarios when to use which one? It is used. Yes. The performance can be changed. I agree with that. Data change, performance of model will get changed. It depends what you need in output. अगर आपको probability चाहिए, तो go for logistic one. If you just need 1, 0 and you want to make 1% tree, if your accuracy is not increasing, go for random forest. Accuracy increase, but it's lead to overfitting. You want to control that, go for gradient boosting. What is your question, guys? Please ask. What are the difficulties which you are facing? Same way, guys, we have done prior also. I think I teach you root node, parent node, child nodes multiple times. RMSE. RMSE value has to be less than 10. Yes. ग्रिड सर्च मेथड नहीं है कोई, ग्रिड सर्च एक कॉम्बिनेशन है उसी का। हाँ कर सकते हो, हमने किया भी तो है। Should I show you? Performance, सिर्फ confusion matrix only given percentage. Rest other is based on RMS value. There is no percentage. हाँ less than 10. हाँ close to 0 is best model. If you see, यहाँ पे हमने मैनुअल लिखा है, ये आपका होगा मैनुअल मॉडल। नहीं करना है, यू कैन डू विद ग्रिड सर्च, मॉडल रिमेन सेम, वो चेंज नहीं होगा। ठीक है चलेगा, कोई प्रॉब्लम नहीं इसको। Guys, please ask a question what you have. अभी इजी हो गया। Then we done after this what we have done after boosting? Naive Bayes. How Naive Bayes works? It works on probability of data. Clear. Then we done KNN. KNN works on distance of data. Easy हो गया। Naive Bayes is only for classification, and it's never used for regression. KNN used for regression also and used for classification also. It's difficult to remember, guys, what type of data required for which one. Guys, any question in your mind, please ask and clear for you. Don't worry. Your question may be right, may be wrong. At least clear it out. That is random. That is not any specific. There is a number of trees, okay, in tandem forest or in gradient boosting. It's basically your decision. Nobody in business or office can give you the best answer. Is to apply grid search and select the best one. There's the only option. मिनिमम उतने ट्रीज तो बनाएंगे, उतने तो ट्री बनाएंगे। हाँ वो हाँ तो उसके लिए थोड़ी सी प्रैक्टिस करनी पड़ेगी। To have a clear click, if someone say, let's say I want to work on terminal nodes. Terminal nodes क्या होता है? हमने तो child nodes पढ़ा है। तो child nodes का different name is terminal nodes. So this may will happens. ये तो logical है, ये हो गई. But you have to practice more. Point number one, guys, for every algorithm, my suggestion at least do practice for 3 data set and come up with the doubts. कि सर ये data set है, मैंने ये apply किया, answers क्यों नहीं आए? First you search for yourself. कि ठीक है क्यों नहीं आ रहे, क्यों आने चाहिए, क्या difference है? अगर नहीं find किया, I'll find for you, no? But at least you come up with the questions along with data. Any other question, guys? Please ask. Comparison means you do not have to compare their formulas or nothing. You just have to compare their accuracy. So model comparison example. कोई है टॉपिक लिखा है. Okay. Let's say you applied on data set decision tree DT. Okay. Your train accuracy is 78%. Your test accuracy 75%. ये clear हो गया? You apply your random forest. You apply your ADA boost or let's say GB boost, XZ boost. आपने चारों apply कर दिया. Okay. GB and XZ. Guys, on what basis we say the model is good or bad? Train or test? मॉडल गुड है या बैड है किसके बेस पे बोलेंगे हम? ट्रेन के बेस पे. मॉडल परफॉर्मेंस ऑन टेस्ट डेटा. यहाँ पे आ गया 80%. Here I got as 85%, and here I got as 81%. According to you, which is the best model? ये क्लियर हो गया? If your answer is coming in percentage, then you can compare. If you have RMSC, you cannot compare. Regression task और classification task को compare कभी नहीं कर सकते. Okay. If you're comparing all the regression, all types of regression, right? Decision-based regression, random forest regression, GB regression, XGB regression, then you have to compare with जिसका सबसे smallest हो, you select that one. This is for all type of regression. Yeah, I don't know 100 less than 10. More than 10. Bad model. Less than 70. Bad model. More than 70. Good model. Correct. Same threshold we have over here. In confusion matrix, we say accuracy has to be more than ये threshold है. Any other question? तो इक्वेट है में 4 लगा दी. विचारों में से कंपेयर करना है कि जिसकी एक्यूरेसी सबसे ज्यादा है. That model is the best model for you. Your question है? Is any other question can please ask? I'm open to any questions. Shantanu, Rahul, Vallabh, Yogesh. Sentiment analysis मैंने आपको नहीं पढ़ाए थे. Sentiment analysis is algorithm. Sentiments means emotion. If, for example, let's say you have a birthday today, and your mom dad has tried to give you a gift, and they purchase the iPhone for you. You're not aware what is the gift, okay? But think like your birthday, and Amazon people deliver the gift tomorrow. How you will feel? You feel bad? That feeling is called sentiment analysis. So when you write your tweet or any comment on the Amazon website, your delivery is very bad. I'm not happy with the service. Okay? You are ugly guy, your company is pathetic, whatever you want to write. That sentence is a naked words. It's a happy way or it's a sad way. That happy and sad classification of any sentence is called sentiment analysis. I'll teach you that. Later, when you go to deep learning, I'll teach you.
That is part of deep learning.
It's a part of it. NLP, not deep learning, it's part of NLP. Natural language processing. इसमें इतना ही डाउट्स था हो गया You have NLP, you have deep learning, you have AI, and some part of computer vision theory. But except all is practical, except the part of the vision one. Everything is practical. I'll take practical. I don't prefer to take full theory. Yes. PC. You do not have to explain it. You have to say that in such a way that after having a 6 variable, we club and make 3 variables. And these are the 3 variables. Okay. These are the 3 variables which will be further used for analysis. You do not have, you cannot explain this. This is a pure maths. It is a multiplicative of beta and x. ये हो गया क्या गया y लगा दो x आ गए कितने पड़ेगा हाउस प्राइस this is the y this remaining or x you apply linear regression you apply your digital regression or any regression whichever you want. Not this. It's not mandatory कि decision tree से answer better आए. ऐसे कोई rule नहीं है कि this is the best one. Data change, pattern change, variance change, the algorithm में differences आएंगे. Because mathematically it's changing. The main thing happens कि when to use which one. That selection is interview questions. After selection, which is the best one? That depends upon the output what you get. Nobody looking at, I can look at the data, can say this data is there, try to go for this algorithm. I can say that. Oh. आप बोल रहे हो कि आप एक एक्सेल फाइल बनाना है जहाँ पे एल्गोरिथम के नाम हो और व्हेन टू यूज वो लिखना है आपको या यू वांट आउटपुट स्टैंडर्ड फॉर्मेट रहेगा ना पाइथन की आप बात कर रहे हो तो फॉलो लिख दो सारे मॉडल्स की हाँ हाँ फिर अलग जाए लैपटॉप इज डूइंग यू डू लंच एंड कम we do in office like this way system will do we just said follow we run the code and we do we look at what सारे मॉडल्स आ गए we know that every model is going to use for prediction ये तो clear है our question comes if regression है तो regression data models classification है तो classification models I know every model will predict okay I know the functionality but which is the best we use a confusion matrix this procedure are standard nobody can I cannot change you cannot change anyone cannot change the only difference in selection of variable for example you have 100x route pick up any 10 random your case have become different 10 randoms answer may change so this will also happens if model change calculation get changed calculation change can I say answer different if you have a data for classification to predict whether a people will get a loan or not if I work on row wise data frequency data, can I go for decision tree? If I work some probability of data, can I go for naive Bayes? और समझो कोई एक probability 0 आ रही है, so what happened? Naive Bayes fail. Agree? So over that scenario, computational difference will be there. There's something that give importance to computational. First importance, when to use which algorithm. Then second, this algorithm, what type of data required? Do we have our or not? Second, how this algorithm works. Did he works on frequency data? Linear regression works on means of data. If you remember the calculation, we have computed X bar, Y bar. So every data have functionality of computation different. So that we need to decide that. Any other question, guys? Ask. I feel like you have some question in the mind, can see from your face. वो random है, वो ऐसे कोई role नहीं है. It's purely random. So can you apply condition paranoid to have 300? But regularly, mostly, his question is, when you use a grid search, in grid search, he has data set of 400 rows. Okay. The condition for parent node and child nodes, what should be the numbers? Correct? That is the question. That depends on randomly. My question, if you have 400 rows, can you apply the condition parent node should have 400? Why not? Tree बनेगा ही नहीं ना, split ही नहीं होगा. So we need to select the condition for the sample should be at least some less than total data. So you can take 100, 50, 120, it depends on us. Can we cross more than 400? आपका डेटा 400 का है. 400 के ऊपर जाएगा क्या? Why not? Tree बनेगा ही नहीं because we do not have a data set only. So your threshold should not cross more than data. Your threshold should not be equal to data. Your threshold always has to be less than data. Then in less than data, what value? It's random. Point number one. Out of random, to select the best one, we use grid search. Correct. You try. Office में 8 घंटे क्या करोगे? This is the job which we do. अगर logically अगर एक code में अगर if I given my code, you just run the code, you get the answer, and you are happy with the answer, okay? But इसमें से best को try करो. That is manual, guys. I also do. You have to do. There is no option. And there is no shortcut. अगर आप लोग कोई shortcut बनाते हैं फ्यूचर में तो मुझे बता देना. ये तो आपको try करना ही होगा. There is no shortcut key for this. Here I take small number because I want to show you output. In company I take start from depth from 182 to 10. Parameter 1 to 500 trees. Leaf 10 to 100. 10, 11, 12, ऐसे combinations. Learning rate 0.1 to 0.9. 0.1, 0.2, 0.3, 0.4, then 0.22, 0.23, 0.44. हाँ तो एक बार रन करके रात को चले जाओ. Come early morning and check. Do for small case. Running for small case. Just increase the competition. What happens? System will take time, na? Keep the laptop on and go. Screen बंद कर देने का, laptop पीछे से ना CPU रन होता रहेगा. If CPU is running means you are live. Means you are doing a hard work 24 hours. So that's the only way, guys. इसमें कोई ऐसा shortcut किसी ने create नहीं किया till now. Always try to get more and more. If you get less than 20%, 10% sensitivity, the model is not good. Okay. Always try to have more and more sensitivity and specificity because it will have direct impact on accuracy. Guys, any question, online students? If not, can take a break, 10 minutes. Guys, I'm audible?
Yes, sir.
Guys, we'll start with the topic called SVM. Okay. I just required, okay, 12 minutes of yours. Within 12 minutes, I'll complete the topic. Means the basic concept. Okay. Guys, we use SVM for both the scenarios. We use for regression and we use for classification. When I say regression and classification, guys, can I call SVM as supervised? SVM is a supervised learning algorithms, okay, which is used for regression also and which is used for classification also. I've taken an example of classification. Mostly we prefer to use for classification. Okay, we do not have any limitations of data over here. You can take any types of data. It's okay. Here I have taken two different types of groups. Okay. You call this as a bad people and you call this as a good people. Clear? This is your X1 and this is your X2. Clear, guys? X1, X2, bad. I just make a normal scatter plot, guys. Nothing else I've done. Okay. In SVM, we have three parameters. One is your hyperplane. Second parameter, we have support vector. Third parameter, we have margin. Okay. And this 3 points, the entire topic lies. Okay, like say in clustering, the entire topic lies based on distance and linkage. Same way, SVM works on only these 3 points. Hyperplane is called as a line which divides two classes properly. So think like this way, these are bad people, these are good people. Can I draw a line? So a line which divides two classes properly. Clear? Good and bad. Concept clear till now? Okay. Distance between support vector, distance between hyperplane. We call this as line. Right? This red dot, the blue dot or green dot, they are nothing but
Data
points.
partition points.
These are called as data points. ये clear हो गया? Update points which are nearest to line. A point which are nearest to is called as support vector. And rest other points we call as data points. Clear? First, every data point is data point. We draw a line. A point which is close to line are called support vector, and rest other are nothing but data points. Clear? Guys, any question? Please ask. A distance between support vectors and a line from both the group is called as margin. Guys, Euclidean one. Concept clear? Easy. So we have to make a line which classify the classes, good in one bucket, bad in one bucket. And the data point nearest to line are called as support vector. Distance between line and support vector is called as margin. Clear, guys? Easy.
They can be multiple.
Vector means multiple. I have taken only 1 point to explain. The first understand with 1 point. Clear, guys? I'll increase the level now. If I can draw one line, okay, if I can draw one line, can I draw this line by small shift H? Can I draw this line? Can I draw, guys, multiple number of lines by doing a small shift? So we can draw finite number of lines. Here, how many lines I have? Line 1, line 3, and line 2. Now question comes, if I can draw one line, I can draw finite number of lines. So I have drawn 3. Out of 3, which line is the best line? Because what is the job of line, guys? Classify. If my line is wrong, can I classify that? No. So next question comes to select the best line, or we can say best hyperplane. To select the best hyperplane, we select the line which have maximum margin. Example, let's say this is our support vector, guys. Okay. Distance of L1 with support vector is 1.8. You know how to calculate equivalent distance? With L2 is 2.9. With L3 is 1.96. Where we have maximum, guys? So which line is the best line for us? And you may have line like this way also, guys, possible. You may have line like this way also possible, guys, in future. But the one, any possibilities is also possible. We select the line which have maximum margin, and that line is the best line for us. Clear? Any question can ask, please.
So we take our perpendicular distance, right?
Distance is distance.
Projection distance.
Yeah, distance. Let's say this point is 3, 4. These are x1, x2 now. This coordination is 3, 4. Example, okay? And this is my support vector. Can we have any coordination over here also? 2, 4. Can you compute distance, guys? उसके opposite में 2 points है. In front of this, इसके front में क्या है? ये point. ये coordination है. यहाँ पे 4, यहाँ पे 3 है, यहाँ पे 4 है, यहाँ पे 2 है, let's say, और यहाँ पे 4 है, यहाँ पे 1.5 है. Can I say this look like calculation by using distance formula? हो जाएगा ना, एक को A रख लो, एक को B ले लो, एक को x1, एक को x2 and calculate. So that distance we calculate. And we select which has maximum. Maximum. Club करना है तो minimum. Distinguish करना है तो maximum. Distance from M1, margin 1, margin 2. What we need? Capital M. Capital M is nothing but distance from both the sides. If you remember, I said this word. हाँ तो point लो ना उनके front में जो होंगे. Okay. Point number 1 is hyperplane. Line clear, guys? So what is hyperplane? A line which separate two classes. Support vector are the points which are close to hyperplane. So now they are support vector. We cannot call data points. Third, we call as margin. What is margin? Distance between support vectors and hyperplane. The support vector come from bad also, come from good also. Okay. If we can draw one line, we can draw finite number of lines. The question comes, which is the best line? To select the best line, we use maximum margin because we need to classify them. If we have minimum distance, we clump. That is clustering. Concept clear, guys? Easy. Line बड़ी नहीं होगी ना? Clear. Mostly. This much is SVM. Easy है. I will increase the complexity more. Don't worry. Clear हो गया? I'll share the screen. There is a terminology I teach you. These are the terms which we use. Are you able to see the screen, guys? I'll see in the screen. Okay. We'll start with one by one. Select. Which is the best line, guys? A, B, or C? Why not A? It is misclassifying. It's not a pure classification. Got the point? The thumb rule is what? A line which segregate two class properly. Clear? Next. C. Why is it C, guys? Maximum distance or maximum margin. And the distance is called margin. Either you say distance is okay, but technical what? Algorithm say margin. Clear? Next. Why you selected A? Why not B? But if you see the distance between B is maximum. So what should we do? Should we go for A? Should we go for B? Rule number one, we should go for A. Got the point? We cannot take B because we have to take A because the rule number one is there. Now this one. Line cast. Okay. Point number one, every data point is data point. We need to draw a line which segregate two class properly. But here segregation happens. If you see the blue coming in red one, can I say classification is wrong? Perfect. It is called as error. Accuracy come होगी ना. If you are able to classify everyone accurately, what is the accuracy you have? 100% is called as overfitting. Now understand why we say this line is possible. The thumb rule say a line should divide the classes. Let's say draw this line, okay? Okay, guys, on screen. What are support vector, anyone, guys? Point which are nearest to line. Which point is nearest to line, guys? Can I say this one is nearest? Can I call this one is nearest? This is nearest, guys? No. So can I call this point as an outlier? Can I say outlier is a data point, no? But it is a maximum we call outliers. Do we have any impact of outlier on the line? No. So SVM say, you give me outlier because I do not have any worry about outliers. If we have outliers in the linear regression, what happens? The model accuracy get reduced. Your beta naught, beta 1 get changed. So that is a drawback of outlier in linear regression. But in SVM say, give me. Don't have to treat also. I'll work with outliers because I works on support vectors. I do not work on all data points. I only works on support vectors. Got the point, guys? Importance. So SVM is robustness to outliers. So in SVM, you do not treat outliers, it's fine. Clear? It is not mandatory over here to treat. Easy. Now this one. Can we draw a line? Yes or no? Draw कर सकते हैं. If I convert this data, applying some transformation, if I make a data like this way, can we draw? This conversion is called as throwing your data into higher dimension. Let's see what is the meaning of higher dimension. If I have a ball, I say throw on the football ground. You can throw anywhere, any direction. See, this is your data. Draw a line. If I say this is X and Y axis, can I throw into a higher dimension? Can I draw a line? This throwing into higher dimension is called transformation. So SVM will make a line only. But which line? This line is on higher dimension. Got the difference? Line he draw करना है. लेकिन if the line is not possible on scatter plot, what he do? Scatter plot is 2 dimension, 2D. Okay? He throw your data randomly in 4D. Square box. 4 dimension. He can throw your data into 5 dimension. Hexagon of 10, 8 dimension and so on. Why he throw? Because he has to make a line. Can you see, guys, are we getting a line over here now? The higher dimension. You see the line over here? Clear. The same way. Okay, let me explain you. Wait. Yeah. So whenever you have a data in this dimension, guys, and you're not able to make a plot, what do? You throw your data into higher dimension. Clear? After throwing your data look like this way. Easy. Now can you make a line, guys? This higher dimension, as a human being, can we see 3D image, guys, without specs? Can we see 4D hologram? Have you seen hologram? वो ना Star Wars में एक image आती है, you communicate with her. It's a light. We cannot see with a normal human eyes, guys. It's difficult, but laptop can see. Okay, so this will happen at the back end. But as a human being, we have a habit of saying X and Y axis. If you see entire world, every class, every road is built on X and Y axis. Why? X. Why? X. We just break and study. Okay. Now at the back end, it's a straight line. When you make a plot on the front end, you get this type of structure. This is conversion of data. This is your front end. Guys, back end पे क्या है? Line ही है ना? But when you visualize, it becomes circle for you. Okay. At the back end, at the front end, we have this one. At the front, when you throw your data into higher dimension, we have this plot. Clear? Any question, guys? But when you throw into higher dimension, for example, when we have 2D, Euclidean distance is easy to calculate. But when you have a big distance, it's become difficult. So at that time, we use a spatial calculation called as kernel trick. There are 3 types of kernel tricks which help us to do the calculation of distance. Clear? So when you throw your data from 2 dimension to higher dimension, that is called transformation. And to calculate the distance between support vector and the line, that calculation is done by kernel trick. Ye clear ho gaya? So kernel is only for calculation. And where he do calculation, guys? In higher dimension. Low dimension pe we have to use a normal Euclidean one. You just rotate your diagram. You take x and y, x1, x2. Add a color, blue and green. Can you make a normal plot? ऐसे प्लॉट बना सकते हो. गुड बैड, गुड बैड. ये x हो गया, ये x2 हो गया, और जो शेप है वो क्या हमारे लिए? How much dimension I'm using? Present in 2D, but how many variable I use? 3 variables. Can you make this one? X, Y, Z. हाँ, तो वो पैरेलल हो जाएगा. तो यार we increase the dimension for you. हाँ, आप कुछ अरे क्या पूछो? No, you don't to ask me. हाँ, so we just convert the data into higher dimension. Simple. 2D है, we just put a plane. फिर again plane. And then third variable will be required. Now, I have taken example for using x1, x2. Tomorrow you will have x1, x2, x3, x4, x5 till x10. Because we do not have limitation for independent variable. Concept clear, guys? Any question on this? We cannot go for the higher one. सबका normal में हो जाएगा. x1, x2, x3. हाँ, इसको हम 3D में convert कर सकते हैं. So 2D we convert to higher dimension called 3D. That is possible. We can do 4D. He is asking if we have x1, x2, x3, then what we do? Clear, guys? Shall I move forward? Okay. What is the first type we have studied, guys? Hyperplane. Second, margin, support vector. Third, margin. To select the best hyperplane, maximum margin. Okay. If we are not able to draw a straight line, then we do conversion to higher dimension. So 2D we convert to 3D, and then we try to draw a line. In higher dimension, when we have to calculate the distance, we use kernel. Clear? ये clear हो गया? Guys, I'll add one more point. थोड़ा simple करते हैं और. हम सिर्फ लाइन ही ड्रॉ करें. हाँ, क्योंकि सपोर्ट वेक्टर के बेस पे लाइन फाइनलाइज हो जाएगी ना. After finalization, first you have support vector, then you have margin. Based on these two combinations, you select hyperplane. Okay, guys, this dotted line is a margin line. Huh? Don't get confused. This is a circle you can see. Okay, This is margin line for bad group and good group. This is B for bad and G blue for good. Is clear? Okay. This line is called as what, guys? The dark color line is called as. ये clear हो गया? A data point nearest to hyperplane is called as. This we call as. But if you see, there are two groups, good and bad. Just 5 minutes more. Can I say a bad people who is a red color coming in good group?
Yes.
This one. The person who is a good, can I say he's coming in the bad group? This one. Bad, good में आ गया और good, bad में चले गया. ये clear हो गया. Now guys, can we call this a wrongly classified? Now to calculate the distance from the data which is coming on the red one, I'll calculate distance from this point till this point. That calculation of distance, let's say I get number as 3.8. Euclidean one, okay? This distance I'm getting as 1.7. So red one, blue one, okay? Distance for red, 3.8. Distance for blue, 7.8. Total how much distance I have, guys? Anyone do calculations? 5.6 now? ये clear हो गया? This type of distance, normal distance, but we call this as slack because this is done for wrong classification data. ये भी distance है, लेकिन guys, these are slack distance now. ये clear हो गया? Now, guys, what I want to say, the people who are coming, the bad people in good, let's say you are 3 and they are 3. Shantanu sitting on the bad side and he wants to come on the good side. And you have only 3 chairs. You will give your chairs to sit him. Donge? If he gives you money, then you may think. This will happen now. That money parameter is called as penalty. एक penalty word है which is made by the scientists. Either we call cost penalty or we can say penalty. How much Shantanu having a distance 3.8, and let's say Yogesh was coming in the good one, but now he want to go and sit in bad one. How much distance we have for Yogesh? So this is for Yogesh. Guys, I'm taking a hypothetical situation, okay? This is for Shantanu. Now you can say I can adjust the seat. क्योंकि हमारा एक बंदा वहां जा रहा है, another one is coming on my one. So we have a penalty. Any number can I give for penalty, guys? The rule for penalty is more than or equal to 0. Or let's say more than 0. Any penalty you can give me? Give me numbers. Any number you say, no? Your learning rate, you can take any numbers. How much? This decided by us. ये हमने कैसे ले लिया? Randomly ले लिया. Okay. Anywhere we have slack less than 2 or equal to 2. Any value is less than or equal to 2. Yogesh. So what happened to Yogesh, guys? This data points we will ignore. Because Yogesh, who's coming in the red one, now we think like he belongs to the community of red. Yogesh was belong to community of blue, but now we think he will belong to the community of red. So this penalty is used to ignore that data points. So 2 minus 1.7, how much remain now in the penalty? Anyone have less than or equal to less than 0.3? No. So how many wrong classification I will have? Only one. Can I say penalty help us to reduce the error? Logical point clear, guys? Any question, please ask. From my side, concept done. This is I've taken the number and explain you. Okay. 5 रहेगा तो दोनों कैसे हो जाएंगे?
5 के नीचे योगेश में इग्नोर कर देंगे, सिंपल में इग्नोर कर देंगे.
From 5 minus 1.7, how much remain? 3.3. 3.3 is greater than 3.8.
Okay, एक ही बार में मुझे लगा पहले केस में से 2 से योगेश का 1.7 तो वही इग्नोर कर दिया.
हाँ.
5 से दोनों को कम तो दोनों को इग्नोर कर दिया.
Because after subtraction, how much remain? Penalty is the money you're giving to him. Yogesh have given how much money? 1.7. Then only you're giving a seat now. How much remains in their pocket now? 0.3. So this 0.3 is a middle person. Now you want to use 0.3. Shantanu want to sit over here and you say we can't give him. How much we required? 3.8. पहले ट्रेन समझो, ट्रेन हो जाए, फिर हम आगे बढ़ते हैं.
ब्लू वाले पेनल्टी माइनस करें तो वो रेड में करना पड़ता है.
हाँ, we'll ignore that data point. So like this.
उसको डिलीट कर, कंसीडर नहीं करेंगे लाइन को.
वो पॉइंट को कंसीडर नहीं करेंगे. And we will think that this become as a red field. तो वो wrong classification नहीं होगा. Clear?
तो मार्जिन लाइन कैसे डिसाइड?
नहीं, वो मार्जिन लाइन मैंने ड्रॉ किया है जस्ट टू एक्सप्लेन यू. ये लाइन नहीं है, ये जो मार्जिन है ना, ये जो डॉट है ना, ये सपोर्ट वेक्टर, इससे जो डिस्टेंस है उसका मैंने एक लाइन बना दी. ये जो सपोर्ट वेक्टर है उसके पास से जो डॉट्स है इसको मैं ऐसे लाइन बना दूंगा. हाँ, ऑलवेज इन पैरेलल ना. अभी ये सपोर्ट वेक्टर्स है, लेकिन हाउ टू नो कि दिस पॉइंट इज सपोर्ट वेक्टर और नॉट? To confirm that we say this is support vector, every point will come below this. Correct? Support vector are nearest point. Rest other point will be below than the nearest one. Okay. Clear, guys. So what are the points we studied? This is a summary. Then what we studied? To control 5 points, your work is done. And if not getting a straight line, we can use higher dimension. And to do a calculation on higher dimension, we use kernel. Kernel is for clear, guys. Now one last point, then I'm done. Guys, in Python or any software, have you make 4D dimension, 4D diagram? Have you make 2D scatter plot? Have you make 3D? Can we make 4D, 5D, 10D? Not possible. So we cannot make plot of this algorithm. It's a drawback. Because none of the software have made who can work on 5D, 60, 70 till now for the public use. Backend we can make, but the front end we cannot draw. It's one of the drawback of SVM. If you want to draw, you take that line, take x1, x2 and draw. Take x2, x3 and draw. Take x5, x5 and x6 and draw. At a time, 2 variables you can use and you can make a diagram. But you cannot make a diagram for more than 2 dimensions, 3 dimensions. Clear? From my side, guys, concept done. Any question can ask.
Where we can use it?
You can use whenever we have a classification task and when we have outliers in the data. If you see every algorithm, we need to treat outliers. In this algorithm, say, do not treat. So can I say he has one more advantage? So people who are scientists, they make algorithm drawback of second and they make a new to have an advantage of that. Got the point? Correct. Online students done for the day, guys. So today you have to give your assessment. You have to submit by today. Okay. They have to do. You already have done. Thank you, everyone.
Which assessment, sir?
The decision tree one, this given on 1 week prior to you.
Okay, sir.
Sir, I have already sent it to question.
It's okay. If you're done, it's okay. So people who have not done, it's for them.
Okay, sir.
Thank you. And please upload on Drive also if you have done.
Okay, sir.